So hi everyone. Uh, my name is Dipanshu, and thank you for. First of all, I would like to thank you everyone for giving so much of support and liking my videos. I'm getting lot and lot of messages on my LinkedIn that you all are liking my videos. I'm getting good response from everyone. Recently, I got a lot of queries regarding the cloud and containers, that how to perform on the analysis on the containers, especially the containers in the cloud natives. So I thought, and also we have surfaced and we have identified certain issues recently where the uh, container clusters were actually being compromised, and the attackers were able to take the reversals out of those pods. They actually created a new pod with the reversals, and they were able to exfiltrate a lot of data. They were able to compromise and control the whole Kubernetes cluster. So we thought of, why not create something which is very critical and very very important in today's days, that because almost all organizations have now moved to the cloud, or are in the process of migrating to cloud, and for scalability, usability, and for cost optimizations, everybody is using the cloud native. And because of everybody is approaching towards cloud native approach, because of the scalabilities and high optimizations, the security to those particular cloud natives have become even more important and critical. Recently, we have written a huge guidelines regarding the Kubernetes security, Kubernetes and Docker security. So I was in a process of writing the full documentation. I thought of sharing with you guys as well, but we have certain compliance standards that have come into place. Because of that, I was not able to share the whole things, but I thought of that I will create something which is already compromised and already malicious type of a scenario, where the attacker was already able to compromise the Kubernetes cluster, and on one pod the containers were and on the containers were running on, and the attacker actually created its own and modified the Docker and Docker file, and he was able to take the command and control outside to the external environment, and then it created a and then it started exfiltrating the data. Uh, in and this actually happened with my friend. Actually, he was running a startup, and when we investigated and identified, we find out these findings. So I thought of writing the whole Docker file for you. I have created the whole code for the Docker file. We'll run the Docker file. We'll understand how the containers are being built. But I will not go into the complete in depth for the Docker details, because that is already available on the internet. What I will be presenting to you guys is the basics of those Dockers, what is important from the forensics perspective or threat hunting perspective. If you're doing threat hunting in your environment, what is more critical when you are analyzing the Dockers? The next, I might come with the Kubernetes, or I might come with the memory analysis for the malwares or the memory leakages, because this is what I am actually interested in. But whatever I'll come with, it somehow will be touching the cloud now. So I thought of sharing those details. This will cover your threat hunting as well, along with the forensics as well. So stay tuned. This will be a very long video, because it will cover all the aspects of the Docker. And in the end, you will understand each and every part when it comes to threat hunting, or the incident response and the digital forensics for it from the Docker perspective, or complete containers perspective, irrespective of which container it is. So let's start. So what is a Docker? Docker is an open source platform that enables you to automate the deployment, scaling, and management of the application using containerization. Why Docker came into picture? Because it gives you the easyability to transfer your Docker through a file, or you can actually store it in in the cloud, and you can write a Docker file and you can share the Docker file with the other developers or the testers or the pen testers or threat hunters. When I used to do the red teaming, the type of when we used to develop the malwares, what we used to do, we used to write the malware on one machine, then put that all the malware on the cloud. We create all the packages and everything. Rather than uploading it on the Docker Hub to download it as an image, what we do, we create a Docker file and we locally transfer it as an AMI to the particular user, so they can test it out in their own environment. So it becomes easy for us, to rather than transferring the whole VMs, we were able to transfer something which is very feasible for us. So Docker comes very handy for us when we used to develop the malware. So why use Dockers? Because it provides consistency across environments, whether it is dev, test, prod, faster development cycles, lightweight and portable containers, microservices architecture support. Because you don't have to transfer the whole VMs with the operating systems, big size of operating system. You can actually store it in the cloud or upload the Docker into the Docker Hub or store it as an image file inside either Azure or AWS, and then you can provide the other means the other developers or the testers to deploy it in the production environments. So it becomes really reliable when Docker came into picture or the containers came into picture. Some of the key concepts and the technical terms that we have to understand before moving to the forensics. This is very important. So what is a container? A container is a lightweight standalone executable package that includes everything that you need to run on a piece of software. And what is image? Image is nothing but a read-only template used to create containers. This contains app code, libraries, interpreters, etc. What is a Docker file? A Docker file is nothing but a script containing a series of instructions used to build a Docker image. What is a Docker Hub? A Docker Hub is a cloud-based registry where Docker users can share their images. What is Docker Engine? Docker Engine is the the runtime that builds and runs the Docker containers. What is a volume? A volume is a persistent storage mechanisms used by the containers. What is bind mount? A specific file or directory on the host is mounted into the container. What is a network? A virtual network to allow communication between the Docker containers. What is a registry? A place where the Docker images are stored, distributed, example Docker Hub, or a private registry, which is either in AWS or Azure or GCP. The port binding maps container ports to host machines. So remember these terms. These are very easy, and if you already knew the Dockers, these are not new for anyone. So how Docker architecture looks like? There will be a Docker client. There will be a daemon running. Daemon is nothing but a process running inside the machine. And there will be Docker objects, which will contain the images, containers, volumes, and networks. And what is the Docker workflow? You have to write a Docker file, build an image from the Docker file, run the container from the image. We will perform all these steps when we are executing the malware. So I have written a malware for you, a very straightforward malware for you, but I will explain that malware and then deploy the container on other machines. So we will perform all these steps. What are the common use cases? Developing microservices, running databases locally, automate CI/CD pipelines. This is very critical. So this helps in the DevSecOps as well. So when we are writing the Terraform scripts, we do not write the whole code we do not write the whole code all the time for when we are sharing the scanning profiles. What we do, we create a Docker profile, we git clone it, we push it, and we commit it, and then we utilize that particular JIT along with the Docker file to automate the CI/CD pipelines for DevSecOps. And we have the isolated testing environments. So what are the components? The component is first is the Docker build, where you build the Docker image from the Docker file, then you Docker push, uploads the local image to the Docker registry, Docker run, creates and run a container from an image. What are daemons? Daemon is nothing but a process that is running in the background to manage containers and images. So we have the components at multiple layers. One is at the client side. At the client side, it will be Docker build, Docker push, and Docker run. Then we have host, where at the host side we have the components running as daemons, containers, and images, and we have the registry, which is nothing but repositories or notary. Notary is nothing but is a systematic way to provide image signing and verification for the trusted content, like something like hash values. You can consider it. Why hash came into picture? You can consider that as the notary. So what is the difference between a Docker and a VMware? Uh, a Docker versus VMware, it's pretty obvious. It's very straightforward. I have bifurcated into certain part. One is the feature, that is technology type, OS level virtualization, hardware level virtualization, isolation level, process level isolation, share host OS kernel, full OS isolation. Each VM runs its own OS. So for an example, this is one VM. If I run Windows Sandbox, it will be a different VM with a different host. But what Docker provides is something at the OS level, where you can run multiple Dockers and multiple images and multiple containers inside one OS itself. So the isolation will be based on the process level. Boot time very fast. It takes some minutes to come up. So if I reboot the machine, it will take uh, maybe 3 to 5 minutes. But this is like run in a few seconds. Resource usage, it is very lightweight, very less RAM and CPU utilization. And for this, though, we already know we have to utilize certain part of our RAM. So for example, for Kali, I have given 2 processors, 4 GB of memory. But for Windows, if you really want, if I'll show you for Windows, I have given like 11 GB of memory with 2 processors, and hard disk is 200 GB. For Dockers, you don't have to give that much. It's pretty straightforward and pretty easy. OS dependency, containers must use the same OS family as a host. So for an example, if I'm running, usually what happens if I'm running Windows and I created a Docker on Ubuntu, it takes, and I'm sharing the Docker file with the person who runs Windows. It will run, but I have find there are some dependencies level, the dependencies issues that I have identified. So what generally it recommended is that whenever you are running the containers, you should use the same OS family as a host. That is completely different OSs. For example, Linux on Windows. Performance, native performance due to lack of full OS overhead. Slightly reduced due to full OS emulation. Portability, highly portable across platforms. Write once, run anywhere. So for example, you're writing in Ubuntu, but you're running in Windows. Go ahead, it will work very fine. Less portable due to OS hardware dependencies. Use case, ideal for microservices, CI/CD cloud native apps, ideal for legacy app, full OS testing, running multiple OSs. Example to Docker, VMware workstation, like I'm using the VMware workstation, vSphere, ESXi, image format Docker image, and which is nothing but your OCI basically. And this is called the VM disk image, which is VMDK. Then summary, Docker is best for fast, scalable, lightweight application development or deployment using containers. VMware is best for running multiple operating systems with stronger isolation using virtual machines. Why forensics in Docker? Because we have minimal visibility, because containers are lightweight and fast, but they don't provide the same visibility as full VMs. Traditional monitoring and security tools may not see what is running inside the containers unless they are specifically designed for it. And it is dangerous. Why? Because processes inside the containers can run unnoticed by the host level tools. If logs are not, and if the logs are not externalized, means any SIM solution you are not storing the logs for the Docker runnings. You can expect malicious activity may vanish once a container is destroyed. An attacker exploits a web app inside a container. Since the container lacks audit logging and runs in a temporary state, the entire attack leaves no forensic trail after the container stops. So for an example, when I will show you as well that when I'm running a container and I delete that particular container, the particular audit log for that particular container is completely gone. So whenever we are performing the forensics, when we take either the VM snapshot if they're running, or if they're running in the cloud, what we say that you export and save both the image and the container so that we can validate what it is going on layer by layer. So I will explain the layers in few minutes, that what layers are. That is a very important part in containers, in Docker forensics. I will explain that in a bit. Then there are container breakouts, which means these are the vulnerabilities that allow an attacker to escape a container and gain access to the host. A major breach of the Docker security model, and we have seen recently a lot of attacks. One is the dirty cow, which is very prominent and very famous. That is for local privilege escalation. What it does is it takes that uh, that it takes the kernel leakages, and then it escalates privileges by uh, using the dirty cow by running the dirty cow exploit. How a user in the container could write read-only memory and gain root access to the host. Another vulnerability is Linux vulnerability, memory management issues that is enabled container escape and root privilege escalation. Another CVE that was identified, Docker command line injection vulnerability via crafted image path could lead to arbitrary code execution on the host. Real world consequences: an attacker who escapes a container can access host system resources, other containers, secrets, or even take over the entire node in the Kubernetes cluster. I remember my time in 2022 in 2021 or 2022 when I was doing the end-to-end red teaming for a client, and we were able to compromise the Kubernetes cluster, and we identified the where exactly we landed by compromising the web application. It was running inside the Docker, but we were not able to escalate out of the running Docker system to the host. So what we did, uh, we check what is there inside the system resources that are being allocated to the Docker. And due to the misconfigurations in the Docker config file, we were able to escalate ourselves, and we actually took control of the host machine. Okay. And from there, we started our journey, and we landed onto the Kubernetes cluster. We compromised the whole Kubernetes cluster. From the Kubernetes cluster, we went to compromise the AWS tenant. We escalated our privileges by compromising the IAM keys. Once we compromise those we escalate our privileges using the IAM policies for the misconfigured IAM policies. Once we configured it, we were able to land into other AWS resources, and we actually compromised the whole VPC. And there were gateways that were being configured as an EC2. We compromised those EC2 gateways as well, and we were able to jump to the other VPCs as well. So this is how we compromised the whole Docker architecture, then leading to Kubernetes, and then to AWS tenant level. So this is very critical when you are designing the Docker and the Kubernetes cluster. Make sure that the misconfigurations should be eradicated. Then leverage for persistence and lateral movement. What it means: once inside a container or host, attackers often plant backdoors or malicious containers to maintain persistence or move laterally across system. This we will see in this particular practical example. So how we do it? We deploy a new container that communicates with the C2 server. So we use the Docker socket, which is running inside the var run docker.sock. to control other containers. We exploit the shared networks or volumes to access secrets from other containers. So how we did it? If an attacker compromises a Jenkins container, they could modify the Jenkins build pipeline to deploy a diversion. Then we use the stored credentials inside the container to access the GitRep or production DB. And trust me, any organization who is currently building the DevOps using the Terraforms or inside the Azure as well, when you are writing the RMI, I think so, AMIs, Azure images, I think we call it. They have the hard-coded secrets inside the Azure, and we have extracted big time those secrets, and we were able to compromise running resources inside Azure tenant as well. So because what developers they do is they when they are writing the infrastructure as a code, they store the hard-coded secrets in that IAC code. That is very difficult to remove once handed over. You can expect the full compromise of the tenants. So make sure when you are writing your codes, you are actually not storing the code credentials inside the Terraform code. What you can do is you can actually create the tokens or the variables and store those credentials inside those variables. We call it as an environment variables basically. You store all those credentials in the environment variables and define the environment variables inside your Terraform code as well. So pivot to other containers using the shared Docker network. Source poisoning or supply chain attacks, this is very common and you are seeing it. Attackers inject malware into public Docker images or dependencies which are unknowingly pulled and used by developers. Example, in 2021, over 30 malicious Docker images with crypto miners were downloaded over 20 million times. Images appear to be legit, Ubuntu Nginx, Alpine Python, but contained malicious script. Supply chain attacks compromises a base image Node 14 and upstream dependency like npm package. And the very famous attack for this is the solar event bridge. Though not the Docker specific, highlighted how dangerous trusted dependencies attack can be. Vulnerabilities as users and providers, misconfigured Docker files. We always know that if misconfigured, you can expect the full compromise of the clusters. So real world example, uh, which we also exploited when we were doing red team in one of the organization that was also running the DevOps pipelines. So how we did it? A cloud-based CI/CD pipeline might run Docker with elevated privileges. If CI runner is compromised, all container and secrets inside the pipelines were exposed. Using those exposed credentials, we were able to take leverage of the whole pipeline and then to the resources to which it was authenticating. It was actually authenticating to SQL DBs and the SQL DBs along with the other other AZVMs. And once we compromise those AZVMs, the path to the gateways and VPC peering was easy. Once we compromise to what means VM nets basically in Azure. Once we compromise those VM nets, we were able to take control of the whole AZ uh, tenant as an implementer. IP credential data leakages in public repos. Sensitive data often ends up in Docker images and get published to public registries like Docker Hub unintentionally. So, for example, if I'm creating a Docker image and uploading it to the Docker file, make sure that the private endpoint IP addresses and the credentials or the other data that is sensitive to any organization should not left behind inside the Docker. Make sure you store it in the server. You make an endpoint call to the server, download the packages from there, and then automate your task from there. Common hard-coded are your SSH keys. We will see this in our example as well, where the SSH keys are being used by the attacker to transfer the data, to exfiltrate the data. Case studies. There is one case study for the Aachen University study where the researchers analyzed 337,171 Docker images and identified that 8.5% contain sensitive data, including 50,107 valid private keys and 3,158 direct API secrets. Notably, 95% of the exposed private keys and 90% of API secrets were found in a single user image, indicating unintentional leaks. Key findings: exposed keys were actively used, compromising over 275,000 TLS and SSHOs, and 20,082 compromised certificates relied on these keys, with 61% being self-signed. And this is the link for the reading. Then SysDig threat research team analysis in 2022 analyzed that 250,000 Linux images on Docker Hub revealed that many contained embedded secrets such as API keys, SSH keys, which could be exploited by attackers. And this is the link for the blog. You can go ahead and read it. Then a very important, a very key finding in 2022, which Bleeping Computer did, that it uncovered over 1600 publicly available Docker Hub images that hid malicious behavior, including cryptocurrency miners, embedded secrets that could serve as backdoors. And you can go to this link and you can read the blog. I will upload all this information on my GitHub repository. You can actually look to this particular blog. These are very interesting and very key findings are there. Now we will start with the practical. Uh, so if I go to downloads, oops, let me just remove. I forgot to remove all this. Okay, so this is my Docker file. Let me open the Docker. Oops, sorry. Let me open the Docker file. Okay, so this is my Docker file, which an attacker created to take the reverse shell, and it has also created a persistence, and it has also not only created the persistence, it has also stored the SSH keys leaked inside your Docker. So how it did it, we will explain, and we will run this as a malicious Docker file. If you are doing the forensics, it is must run for you guys. So what this the Docker files or the Docker image is, that from Ubuntu 20.04 means the version of the Ubuntu update, then front-end non-interactive, install netcat, curl, vim, wget, python 3, cron, systemctl, OpenSSH server, and add user at attacker, means the username of the attacker, then echo attacker 123, then change the password, create a home directory for the attacker, and grant the ownership of that attacker directory to attacker this particular directory, then create a fake malware script inside the this. So this is, I have added it to showcase this is not required actually, but I have showcased it to make you understand that which files to look in, where does this file stores. For example, you will not get the Docker file directly. How I have created, what you will get is the Docker image, but how this Docker image is being created, what could be the issues at the backend, or what attacker might be running. That is why I am showcasing this the Docker image to you. Sorry, the Docker file to you, the code inside the Docker file. Okay. Then it is just a fake data that I have put it in the malware.sh. Then I am downloading the payload from my malicious website, and I'm storing that particular malicious code inside the malware.sh, and I'm giving an executing permissions using chmod. I'm creating a reverse shell. I'm storing the reverse shell information in the revshell.sh, and this is the reverse shell command bash -i dev TCP, and I'm taking a reverse shell on this private IP. This is nothing but my Kali IP only. Usually we generally the attackers, they don't store the bash history, but when we identified the but usually attackers forgot to remove the information from the bash history, so you will identify a lot of information in the bash history. And this is then for persistence. I'm creating a persistence by running the cronjobs. Then I'm creating a directory using the backdoor.service, and running that particular backdoor. I'm creating an SSH key, and I'm logging in with the user attacker @evil.com, and I'm storing my keys inside the attacker SSH hidden attacker SSH directory. This dot. Okay. And this is the encoded payload that I will be running, and which is stored inside the encoded payload file, and I'm taking the reverse shell. Usually you will not get this Docker file, this will be deleted, but what you will get is this. So let me just check if there is any image running. Oops. Okay. So let me check if any container is there. Let me just delete the container. Okay, we can't delete it. Why? Let me try this. Okay. Okay, nothing running. So far so good. So let me just build the Docker image -2 at Docker lab. Just building the image. Let's check the images. So there, yes, we have the image name as attacker lab, tag latest. This is the image ID when it was created 31 hours ago, and what is the size of this Docker is 238 MB. Okay, so far so good. Now we need to run the Docker. So what I will take, let me just take the netget shell here itself. Okay, sudo docker run. Let me just take the netget shell at 444 docker run -name lab -30. Let me just name it as the attacker lab 1 and the name of the image. Okay, so we got the shell as expected. Who am I? Attacker, pwd this, ls this, and we have data here, base 64 as expected, cat malware.sh as expected, cat revshell.sh as expected. But let me just exit it. Let me just take the netcat and let me just open the Wireshark. So we will start the what we call it as the real forensics. So we will start the forensics from here. We will run the TCP dump on port 4444, and let's see what happens over there. So let me just name it as attacker lab 2, and we got it. Let me just run it as ls-l cat encoded underscore payload dot base 64 cat malware dot sh cat revshell dot sh. But this is something that is okay. But what we want is to analyze what is going at the backend. So I will close this shell, and I will look to the TCP dump Wireshark ref shell packet. And if you see over here what is happening at the back end, if I just follow the TCP stream from here for easiness, after taking the reverse shell, the attacker ran the whoami command and it encoded the things, and this is running smoothly as there. But what is happening, that attacker was able to take the connectivity from this. So it means this is the IP of the Docker. How we will identify the IP addresses and all those things, I will just list down in few minutes. But just understand what is happening at the background. That this is the source address, means the compromised machine from which the attacker has taken the reverse shell to. So when you are analyzing the machine packets and machine network, if you are lucky, you able to get it. Run the Wireshark, run the TCP dump, you will definitely get a lot and lot of stuff. So always remember that whenever you are running it, you should run with the Wireshark, so that what is going in the network, you should be able to know. Here are certain stream bits that are being shared between the attacker, and this is the close calls and retransmission, and I think duplicate acknowledgement, retransmission. So this is what I wanted to showcase at the back end, that whenever you are running the network, that always start with the network analysis, that what is going at the back end. Now let's look at some of the commands that whenever you are starting with your this thing analysis, you should start with what is the current Docker version that I'm running. This is the current Docker version I'm running on this architecture, and this is the what we call it as the on here. Then I will write the Docker info. Okay, the information about the Docker. So this is the version of the Docker, default context, included. This is the path where the Docker build X is there. What is the server version? Server storage driver overlay, file system, extended file system, support, and is there any native overlay difference? True. This is the network bridge host, what type of network I'm running on, what sort of plugins I have, and this is the name of the machine on which the Docker is running. So for an example, you got the VM snapshot that was compromised and which was isolated in the cloud and was isolated, and the snapshot was created from there, and the snapshot is being given to you to analyze it. So this is how we start basically. Okay, let me just check if I always run with -a. So these are the two Docker processes that are running on. Let's check what are the images. We have one image that is running. We have two containers. Just run container ls. Spelling mistake. Yes, we have two containers. Usually, the command sometimes is not show. So what you do is you do the node file. Yes, you will be able to see the information. Usually, it's bit of posh posh, but the what we are interested in this. So let's start with inspecting. So the very first command I'm running is inspect attacker lab. So once I do the inspection, this is the SHA value of the on my image that is running on. It is stored. This is the environment variable path. This is the command that it is running from. It is running on the working directory or the user directory is attacker. It is running on Ubuntu 4. Then these are the lower directory information. These are the layers. Now let's come to the what we call it as something which is very important, which is very critical. That what layers are very important aspect when it comes to the what we call it as the Docker. I will explain that, but just as of now, what it contains it contains the information or the blobs values against which the individual file system changes, such as any additions or modifications or deletions that make up the complete image. They are stored under the blobs directory. I will showcase the whole OCI image for that. But as of now, just bear with me. But remember that this part is very important. This is the building block for any what we call it as the any building block for any forensics, because this will give you the tag time. Okay, when it was being tagged, this is very critical. Make sure that whenever you are inspecting, you start your inspection from here. What are the layers? So if I have to run on the sudo docker, what we call it as the inspect, I think this is the correct command, -for format. Yep. So this will tell you the okay, that is my one. That is template parsing. I don't know what's the issue. This shouldn't be the process ID. Maybe I'm let me just check container. Containers are running. Let me kill one container. So let me kill this one. Click done. Exit it. Yes. Let's kill this one. Now sudo and oops, sorry, no, it's done. Sudo docker run -console log let me take another file from here. Log this other components. Format this Let me just find on the same panel here. So we are running it. Sudo I think there is some issue with the process ID, or maybe it is running yes minus here. Let's look at the document. Yes, it's running and process this. There's some issue with the process identification, but no worries. We'll see what is the issue with the process with this. But let's the very first thing that we will do is docker save docker file attacker one, and we will save the attacker lab to the attacker lab.tar. Let's save it at what is running inside the image. Okay, let's see if we got the tar file. Yes, we got the tar file. Let's create the attacker lab image. Let's chmod 777 attacker lab image sudo tar minus xf attacker lab tar minus c attacker lab image. Okay, sudo attacker lab image. We'll get so this is sorry for the interruption, guys. My machine some issue happened with my headphone, so I will start where I left it. So my humble apologies for that. So there is a small glitch happened with my headphone. It got disconnected. I didn't know, and I was speaking, but it didn't get recorded. So I will start it from till the point it was recorded, and we will start it from there. So we were on here that the particular thing is nothing but the OCI image. Okay, so OCI image is the layout structure for for your Docker point. Let me just reopen it, reinitialize the session. So if you sudo cat OCI layout, you will see that the current OCI layer, the image layout version is 1.0.0. What I will do, I will explain each and every part of this particular OCI. This blobs is nothing but it contains the complete information about the layers and the configurations in form of tarballs and so on. So if I go to blobs, I do ls, it contains in the form of SHA-256. So for an example, let's take example of this. I will explain how the layout structure is and how we can analyze this in the form of data, or how we will extract it. I have written the code to extract each and everything. So let's say for an example, we want to extract this particular this. What I will do, I will create sudo mkdir. Let me just copy this sample. I will make it as sample sudo chmod 247. Oops. Let me just clear it out. Sudo chmod 247 sample r minus xf. We'll make it to sorry. Forward 50 minus c, and if I do the sample, if I code the sample, you will see the complete information about the current running Docker image. So what these layers are, as I mentioned, that this is nothing but the individual file system. So for an example, as an original author, you created a Docker file. You created a Docker image, and you are making a lot of changes inside that particular Docker. Okay. So, and now what Docker does is it creates in its OCI layer structure. It creates keep on adding the hash value to the original file system. So for an example, there is a base layer system, and you added some command over there, and then you ran that particular command, and you save that particular shell, or you save that particular bash file onto the Docker itself. So what Docker will do, it will write the particular things in a particular in the same file system, but with a different hash, so that when you are going back, and when you are traversing back, and when you are investigating or inspecting the Docker image at the back, you are reverse engineering it. You will know which particular layer to look at. Okay, so layer is nothing but individual file system inside the Docker image, where the changes have been made, changes like additions, modifications, deletions to the complete image. Okay, and they are stored inside the blob directory. Okay, so for an example, if I do Docker history, let's suppose, let me just do a Docker history. Let me just clear it. Sudo Docker. Let me just check what is the images. So sudo Docker history. And you will see that these are the changes. If I see, let me just make a note trunk minus no trunk. So if you see now, little bit of let me just see if you are able to see that. So I hope you are able to see the changes inside it. So for an example, this is the hash value of the reverse shell that was being executed, and the hash value of the user attacker is missing. But if you see that there are some changes that are being made inside this particular here, and which was added with the comment this, then certain other commands are being ran. To do this, there is a very good tool, diff. You can go and analyze it, but I like to do it raw. So if I do it Docker history, I actually do it from the manifest file. Basically, I will come to that attacker lab no trunk. I'll come to know when it was created, when it was who created it, what is the size, and what is the comment. I do nothing, but I save inside a text file. For an example like this, if I'll say attacker lab
image history dot txt. Oops, I think we cannot create it here. Why? If we can't create it here, then we will create it inside samples. So we'll go to sample, sudo sublime attacker lab image txt. And now if I do this, you will be able to see that. Okay, or you can just paste it in the Excel sheet. You will be able to create it inside a table. So let me just do that for you. Otherwise, I am least bothered about history like that. However, let me just do it for you so that it becomes easy for you. I'll just open it, paste it, and let me just put a table to it. Okay, let's put this. Let's put borders, and let me just do that text. Let me just do go height from 15, so we come to know what is there. Now you can just do the bit of here. For an example, you can go to data, and you can just go to text columns, and you can just do next, and you get the data in the required format. So here is the data. Okay, this is how you can do that. Okay, now if you can see, you can get the attacker values, like what is there. You can just do some more refinement, and you will be able to do it. So for an example, if I go, there is a run command, there is an echo command, and there is something like a lot of stuff is going on here. For example, this is of concern, some cron job is going on, and some other stuff. So you can do a bit of formatting. I just do it in this way. So remember that. Okay, let me do this. So remember that what layers are. Layers is a very important terminology when it comes to the forensics. Layers refers to the individual file system changes that are being made to the original image, such as addition, modification, deletions, and then it make up to the complete image, and they are stored inside the blobs directory. So I'll come there. Oops. Let me just delete sudo, or because I have to compare it somewhere else as well. So let me just delete it. I hope that is clear. So let's come back. I don't know what happens to my Linux skills. Okay, fair enough. Now next is your index.json. Index.json is nothing. It points to the manifest.json. So index.json actually helps you to find where is your manifest.json is going on. Let me just do JQ if works. Yes. So what you can do is, so how it has been written, this is the schema version 2, media version, media type application, VND OCI image, index v1 plus this one, which is correct. Then what type of media type it is nothing but your application that is running and stored in the JSON format. This is a digest SHA-256 value for that. What is the container name? And it is the latest. So let's look at the most important file, which is the manifest file. manifest file is very, very critical. It is written bit of jargon with a juggle, so we can do nothing but JQ. So very, very important. We will understand and we will learn and we will see this. Always remember that the layers inside the manifest file are being updated. Okay, oldest at the top. Okay, for an example, if I am started making changes, the changes will be done at this level. Okay, so for an example, this will be the oldest, this will be the second one, then it will be the third one, and then it will be fourth, and then it will be fifth. So oldest to newest, up to down. But if I'll say okay, so if I made any change in the newest, it will be stored in here. Okay, for example, if I do the split horizontal, let me just do a bit of this and let me put it here so that it becomes, and if I do sudo docker history attacker lab, that's the image name. Now if I compare both of them, just do it again, that it becomes, this is the oldest image entry. Okay, so sorry, this is the newest image entry, so it will be like this, bottom to up. Okay, oldest will be, oh, I think copy paste. So oldest will be from starting from here. Okay, oldest will be starting from here. Now how we can go ahead and start running out and looking to each and every layer that is important. What I did, I developed a bash script. Let me just, okay, let me just do sudo sublime, and I have written the manifest extractor from blob because we want to analyze this. Okay, let me just do it. Okay, so what is going to work? Let me just replace this spaces first. Okay, it looks neat and clean. Fair enough. What I did, I let me just change the path. Manifest attacker. This is the this is the name. Yep. So I'll just change. Sorry, I'll just change this name to here. So what it will do? It will go to this particular directory. It will identify the blob directory. For an example, bin/bash, that is bash file. It will check for the directory where OSCI image is extracted. This is the path of that particular directory. It will create a new directory called as layer directory. This is the code for that. Then it will go to the OSCI directory. It will look the manifest.json. Then it will go to the layer digest. It will do the -q minus r layers and the manifest file. It will go one by one, means it is incrementing. Then it will look for the extraction. So it will create a loop. It will into each and every loop. Then it will go to the tarball file. Okay. And once it extracted, it will extract into the layer directory. And then once till the time the manifest.json is not completed, it will go one by one in the loop. So that layer num plus plus. And then it will do the basics. It will check for the time, service, and all, just to make my life easy. So I wrote it. So let me just chmod plus x manifest extraction. Okay, so see that it has started doing analysis and it has started providing all the information, what is being run, where it is being run, what are the commands, what are the values, everything in the layers directory. So let's go to, and it has created a layers directory. Let's go to layers directory. Let's do it. We have layer 1, layer 10, layer 2, layer 3, layer 4, layer 5, and layer 9. So let's look at the CD layer 10 because that will be the newest one. It has nothing. Let's go to layer 1. Okay, so it has the complete manifest, this thing. So what we can do is, let's look at the all the shell scripts, which all shell scripts are there. Sudo find layers. Oops, let me just sudo find layers minus type. I think this is the command. I want the type file. Then I want anything that ends with the sh. Yep, so I got malware.sh. It means it is stored in under layer 3. So let me do a quick horizontal. Let me just little bit up so that we are able to see what we want. Okay, and sorry, sudo cat layers layer 3 home attacker and create a malware.sh. So here we are able to find the malware.sh was created inside the layer 3. So when this particular file was being created from the Docker image, it was stored under the layer 3. So for an example, I want to see for the revshell, what exactly is there under the revshell. So I'll go to layers, layer 4, home, attacker, and revshell. And I got the reversal information. Okay. Let's look at something which is, here is some macros that are being there. I don't know if I have created it or not. Sudo cat layers layer 2 user share vim. I think this is being created with the vim when I was installing the vim. Oops. Yep, it is just to start the vim editor. Okay, so now let's another point. Let's suppose that where the point where you are going to investigate, or the organization where you are trying to investigate, they say that we cannot give you the VM, or we cannot give you the details about the OS. We can only give you the Docker in the form of tar file. So what you need to do at that time, you need to ask them to give you to run what we call it as the save. So for an example, sudo docker save and whatever the name of the image, lab2, or okay, so save it in the tar file. But what you need apart from that is the complete container information. So that was the image information. You also need the container, sorry, the container file system, so that when you are doing the complete end-to-end analysis, your containers and all other information is running with the you can match and compare the running information and the file system in that particular container, the affected container. So let's suppose this is the current container. So I will do sudo docker I think the command is export my attacker. I think attacker lab 1 attacker container dot tar. I will do that. Sudo mkdir attacker container. Okay, this is fine. Let me just sudo tar minus xf was the container name. Attacker container sudo tar minus xf container. So let's see what we are able to extract. Attacker container here, and here is the full file system in the attacker container, which is easy to identify. Okay, so let's start identifying the artifacts inside it. And this is very easy, convenient for the container, but I will still suggest that images, the layer by layer structure for analyzing the malicious activities or something which you are investigating under the IR is very useful and reliable. I have seen many forensic investigators that they don't save the image and then they don't go layer by layer, and and it becomes very difficult for them to perform the forensics. So we can start with the very first artifact, which is nothing but the bash history. Always remember that the very first thing that you should check is the bash history. So we'll look for the I think attacker. Let me just, I am inside this, so I will go to home attacker because most of the things will be present here. Okay, so I will check for the very first thing is the bash history. So what is the commands, what is the information that I can get it from the history, like what is being ran when the attacker took the reverse shell, what are the data that he exported, what is the information that he has gathered, is all saved inside the bash history. So make sure that you check bash history very carefully. It contains all the information that you are looking for. Okay, then the very second thing that we will look for is the malware script. The malware script ran is stealing data. Payload is being downloaded from malicious.example.com. So when I was okay, so I really wanted to show the real time, the real execution, but due to the confidentiality, I actually asked my friend that I will remove the information from there, but he insisted not to showcase those particular things. But this is the look-alike malware which hit my friend's organization, where the attacker compromised the cluster, and on one of the cluster and inside the cluster on the slave node he created a running pod. Inside that pod he created a docker, he manipulated one of the docker running, and in that docker file he actually ran a new pod, and from there he ran all the scripts and everything. He downloaded the malware. So once he downloaded this payload.sh, he ran this payload.sh to download the full-fledged malware onto machine, and that malware actually the reverse shell on the onto the attacker server, which we saw with the Wireshark. Okay, so let's code what is there inside the I think base64. Yes, let's decrypt it. Sudo base64 this, and we got it that the attacker ran the shell script after downloading from and saved it in shell.sh. Once it and he downloaded another shell file, sorry, basically after the malicious.sh, he downloaded another file that is shell.sh to create a shell. So let's look at the cron jobs that he ran. So let me just go back. Let me just see the var spool cron. I think this is the correct one. Oops, we cannot. Let me check. Okay, sudo cat. Let me just check if we can run it directly from here. Okay, we can directly run inside of the cron tabs like this, or else you can do this always -r cron tabs, and then if you go to cron tabs, you'll be able to see that there is a tracker file. Let's look at what type of file it is. It is a sky file, and let's look at the sky file. So there is a cron job that is running. Let me tell you how this cron. So cat attacker. That what this cron job is all about. So this is the day of the week. This is the month of the week. This is the day of the month. This is the hour, and this is the minute. Sorry, minute. Okay, so this means each and every after second, minute, and day it will be run. Now let's explore the system.services. Sudo. Let me just. Oops. Let me just look at. When I was exploring it, I was able to find some other stuff. System backdoor.service. Let me just clear it. Do it. Backdoor.service. So inside the system folder, in the system directory, it created a backdoor. Okay, that whenever the user starts the machine, the reverse shell should start. Okay, as a service. So let me just do it. Inside system. It's been so long. Okay. Okay, fair enough. Let's look at for the SSH keys. Sudo container attacker. I think this is the directory. Yes. So this is the RSH. Sorry, key that is stored over there. Now you can even do more of the stuff. So if I am the attacker, what I can do is I can just sudo docker inspect state attacker lab. This is running on process 0. I seriously have no idea why it is running on process 0. So what you can do is you can gcore memory dump and run with process 0, because it's failed to do this thing. So I don't know why it is coming with this. And then you can run the radar tool. What I suggest is you create a full you use the line tool to create a full image of this particular full memory dump for this particular machine and then start analyzing it using volatile, which I will cover in different tutorial. For this is the Docker end-to-end forensic analysis. Memory analysis is usually not part of the Docker, but I do it personally because many times I have seen that if that Docker is running from the Windows machine, uh, that Docker is executed on the Windows machine, you will definitely find something running inside the memory. I have covered a lot of memory-based malware tutorials. Please do check it. Some of my videos, you will definitely identify those. And in future, I'm going to create more videos on that. Okay, so this is for now. I really recommend, you have given so much love to me. I really, recommend to go and purchase my book, which which contains the end-to-end information about these things. The book is very cheap, and you can go and buy. It's, I think, not even like, I think maybe 10, no, not, I don't know, maybe $6-7. I don't know what's the rate right now going it for dollars, but it is just for around 710. One copy will, if you buy one copy, what I do is the share that I get, I donate that particular share for the greater cause. Right now I'm getting very good response for my book. I really recommend you to read the book. It has lot of things like this. If you have liked my video, please do subscribe, share, and like my video. Thank you so much. Thank you. I will be creating more videos in coming days. Thank you so much.